Alright, this is going to be a guide to gas recycling in Space Station 14. I'm doing this on Frontier since that's really the only place where this is useful right now. Stations currently have miners providing infinite oxygen and nitrogen, so recycling to get oxygen and nitrogen back isn't very useful there. But the long-term plan for Station Side Atmos, if you've read the documents, is to eventually get rid of those miners, so we'll see if that changes in the future. Anyway, there are 4 types of recycling, 2 of which we actually consider useful. You can use a recycler machine on nitrous oxide and carbon dioxide to get nitrogen and oxygen respectively. You can decompose nitrous oxide into nitrogen and oxygen, and you can decompose ammonia into nitrogen. On Frontier, we care the most about oxygen since you need a lot of oxygen to make freeze-on, so the 2 reactions we care about will be feeding CO2 into the recycler and decomposing nitrous oxide. The other 2 I'll show off but are very niche, so don't expect to actually use them. To start with, let's talk about the recycler. This machine takes gas in its inlet pipe and moves it to the outlet pipe. If certain conditions are met, it will recycle that gas that passes through it. Specifically, the temperature needs to be above 573 Kelvin, and the pressure needs to be above 30 atmospheres, or about 3040 kilopascal. Recyclers can be upgraded using a capacitor and manipulator to reduce those requirements. Back in the primary config. Now when you check it, it'll say the minimum temperature has decreased and the minimum pressure has decreased. Those new requirements are 518 Kelvin and 1946 kilopascal. So the goal of our setup is going to be to have a system that keeps the pipe hot and pressurized, then loop it around the recycler with a filter. So let's get to building. Alright, we'll start with a filter. Coming out of this, we'll need a T-junction, and then 2 T-junctions up here, and we'll want a sensor. We're going to set this to carbon dioxide because that's what we're going to be recycling. Turn it on. We're going to have an inlet pressure regulator just in case. And we're going to need a pump. And this setup here is to make it so that we have a pressure release just in case things get overpressured in this pipe. I'm going to spawn it in with a storage canister. And then we're going to connect our carbon dioxide to this. So since we have this upgraded, we're going to set this pressure pump here to, close the UI, 2000 kilopascal. If you don't have it upgraded, then this will need to be above 3000 kilopascal. This we will set to 4000. And this is just so that if this pipe here ever overpressures, it doesn't get clogged. This can be on the whole time, and this can just be at like, I don't know, 500-ish. So now we're removing some carbon dioxide. Should be all filled up now. Perfect. So currently the input temperature is too low, but our pressure is high enough for this to work. In order to get our temperature higher, we'll need to build fart. If you've seen the other video, then you know what's about to happen, but basically we're burning tritium and oxygen together to make very hot water vapor, and we'll be using that to heat this setup. So we'll need a burn chamber with an igniter. So I'm just going to do it through the spawn panel. Igniter. we bring this down? Let's do here. Now we've got some hot water vapor. Then we'll need a control setup, so that's a pump. We can do this through construction. That's a pressure pump, a signal valve, and a volumetric. And then additionally, we'll need an air alarm. I'm just going to spawn that in. Obviously, if you're doing this yourself, you'll need to actually have a wall and to construct this on it, but for clarity, I'm not going to actually build a wall since walls block the view. This we're going to have like 10 for now. We can fix this later. It's set to max. So the idea is if we ever need this to be warmer, then we will bring some hot gas here and just inject it in, and then it'll get filtered off here. So to set this up, we will be setting our multi-tool to list to connect this sensor. We will add it to this air alarm, and then we will change our settings so that it stops complaining about the fact that we have a bunch of carbon dioxide in the pipe. And instead, we will emit a warning if our temperature is below where we want it. Again, since our recycler is upgraded, it can be a little bit colder. So we're going to set this to like 530. Come on, 530. That should be below 530, not above. There we go. So now if the temperature is too cold, this air alarm will be emitting a warning, and then we can change our multi-tool to link. We can link our air alarm to this signal valve. So under normal conditions, it's closed, but when we receive a warning, it'll open up. Now we can see the temperature rising, and then we control how quickly it rises by adjusting this pump here on the left. So I'm going to set it up to 100 to see how quickly it goes up. You can see as we're heating it up, we are increasing the pressure, which is why we have this valve here, just in case it gets too hot. Once we get to 520 or so, our recycler should kick in. And you'll see it emit a bunch of oxygen. So we just turned all this CO2 into oxygen. Now we need to get this oxygen out of the filter and put it into our storage. So that's easy enough. We'll just put down a filter. Set it to pull out oxygen, and then we'll pipe it over. Then let's color the pipes so that we can have a better idea of what's happening. Those are all oxygen. Up here is our water vapor. On the right, we've got carbon dioxide. And in here, we potentially have a mix of carbon dioxide and oxygen. Or I'm going to color this carbon dioxide to make it clear that that's what it's pulling out. And then finally, we do have some other gases in the outside of this. It's going to be mostly water vapor with a little bit of nitrogen. The reason the nitrogen is in there is because this room that I built the burn in had some nitrogen in it. So we need to get rid of this gas. To do that, we're just going to spawn these things that don't have glass. Where is the hollow fan? Going to need a fire axe to pry up the floor panel. Oh, I can't do it because the window. And we'll need a passive. And we'll close this off. So we're just venting the waste out to space. Now we can turn this pump back on and we should see this pretty consistently make oxygen for us. So if we watch the output of this filter here, that's what I'm looking at with the gas analyzer. We'll see the carbon dioxide get warmer, and once it's above that temperature, we should see the filter start pull a bunch of oxygen out. That's carbon dioxide recycling. And then to show you the less useful reaction, we're going to swap the carbon dioxide for nitrous oxide. There we go. Let's get... How do we get the carbon dioxide out of the system? It should get rid of itself soon enough. We set this to nitrous oxide. And this instead will be nitrogen. So we'll recolor the pipes real fast. So when you recycle nitrous oxide, you get nitrogen back instead of oxygen. Nitrous oxide. But otherwise, if you want the nitrogen, it's the exact same thing. Gotta wait for the pipe to clear a little bit. That'll be good enough. Turn this on. Should start getting nitrogen in. Gotta wait for it to warm up. But once it hits 515, see it pull a bunch of nitrogen out of the pipe network and filter it off. Actually, real quick, I'm going to delete this so you can actually see it show up in the pipe. But yep, we're getting a bunch of really hot nitrogen. If you actually want to use this stuff, obviously you'll then have to find a way to cool it down. But this is how you turn carbon dioxide into oxygen and nitrous oxide into nitrogen. Obviously, you don't really want to turn nitrous oxide into nitrogen because you don't care that much about nitrogen. But the carbon dioxide one is very useful. So we'll go over what you want to do with nitrous oxide next. Okay, for nitrous oxide, all we have to do is get it hot. It's really easy. There's no other requirements, no pressure, no other gases needed. It's just make it hot, 850 Kelvin. Nothing else, no special machine needed. It's real easy. So what we're going to do is a similar loop, but this time without the recycler. We'll get our filter set up. We'll place it here. We'll need a sensor. We'll want our T-junctions. Actually, I'm going to put the second T-junction here so that we have it in a direct line with where our water already is. And we'll get the T-junction here, same as before. We want a way to release pressure just in case. For nitrous oxide, it's way less likely to actually happen, but just in case, it's nice to have. With the inlet pressure regulator, a pump, a port, and we just need to do the piping. Sure, we'll do it this way. And then same control setup as before with a pump, a signal valve, and a volumetric. And we'll need our air alarm again. And then we're going to need 2 more filters because this decomposition creates both nitrogen and oxygen. This first one's going to be for our oxygen. Second one's going to be for our nitrogen. This top one up here is for nitrous oxide. Let's get these connected to their correct locations. Let's do coloring. And we'll have a little storage canister here. And the reason we use the storage canister is because it adds a lot of volume for very little effort. So if this ever does overpressure, if this loop here ever does overpressure, we have a lot of volume to absorb that pressure into and then slowly trickle it back in. So we'll turn these pumps on. We'll set it to like, I don't know, 500 again. The pressure on this one doesn't matter, so I'll just set it to like 300 as a demonstration that it works even at relatively low pressures. This one should still be max. This one should be at like 50-ish to start with. And then let's set up our air alarm. So link our sensor to this. Gases. We should see nitrous oxide in here. And then we're going to have our temperature for warning be below 850. Come on. There we go. So if we're ever below the correct temperature, we get a warning signal, and then we can link our warning to this. So if we get a normal, we're closed, but if we're warning, we're open. And that should start heating up this pipe. We can see it's being a bit slow, so we can up the pressure on this a bit to, say, 100. Now it's heating up quite a bit faster. And once it reaches 850, you should suddenly see a bunch of nitrogen and oxygen be produced. And that'll refill with cold nitrous oxide from the right, which will cool back down, so we need to reheat back and forth. So to make it a little bit faster, we'll increase the pressure on this to like 300. See, now we're decomposing our nitrous oxide into oxygen and nitrogen, and it's that easy. The final reaction is between ammonia and oxygen, which react to form water and nitrous oxide. This reaction is pretty much exclusively used only in theory for a Vox station, since Vox breathe out ammonia, need nitrogen, and do not want oxygen. Of course, the reaction produces nitrous oxide, not nitrogen. But with the previous stuff we talked about, recycler or decomposition, we get the nitrogen added to the nitrous, so effectively this is a way to turn ammonia into nitrogen. If you're on a station, you can also use this reaction to make nitrous if science needs it, but oftentimes the station won't have ammonia on hand either, so debatable whether or not it's actually useful for that purpose even. In any case, for this reaction to occur, you need a mix of oxygen and ammonia at temperatures above 323.15 Kelvin. The reaction occurs fastest when there are 3 times as much ammonia in the mixture as there is oxygen, but the reaction will always consume equal amounts of oxygen and ammonia to make the nitrous and water. So our fuel mix will end up being 50-50 in the end. To get to constructing, we'll start with a mixer for the fuel. Mixer. Flip it around. Pipe in our ammonia and oxygen into it. And to start with, since we want mostly nitrous, mostly ammonia, can't talk today, we'll be setting it to 25% ammonia and, 25% oxygen and 75% ammonia to get that 3-to-1 ratio. Then in the middle, we'll have a filter loop, and we'll just have it here and here. The top one will be for water vapor, so we'll connect it here, and the bottom one will be for our nitrous, so we'll connect it there. And we'll be looping this in a circle. And we'll need a signal, or sorry, not a signal, we'll need a sensor. A a cross intersection. We'll need our pump setup from always for this water vapor to provide our heating. Not a sensor, I need a signal valve. And then we'll just have one more pump here. Technically, don't need it, but to be able to control how much gas we have in our loop. And let's construct this all. And then we're going to need an air alarm. Turn off all regular stuff. For temperature, again, it's 320, give or take. So let's just set it to 320 to keep it warm. And then we don't care about anything else. So turn these all off. Then we'll link it. So under normal, it's closed, but with warning, it's open. We turn this on. And then this, let's set it to like 300 kilopascal. Turn it on, and that'll fill this up. And then now that it's full, we can switch this back to 50-50 for our actual fuel mix. So once this actually starts reacting, it'll refill itself correctly. All right, and then the last thing we should need is, before we do that, let's paint our pipes. So this is a mixture. So now if we turn this on, should see this heat up, and we're producing our nitrous oxide and our water vapor. So it's a fairly slow reaction, but it is a way to turn ammonia and oxygen into nitrogen eventually. And that little bit of nitrogen is again from this up here. We have nitrogen in here, but ignore that. Producing little bits of water vapor and little bits of nitrous oxide very slowly. And that's gas recycling. 2 useful reactions, 1 less useful reaction, and 1 absurdly niche reaction that you really should never use. Essentially on Frontier, it acts as a way for us to turn nitrous oxide and carbon dioxide into the gas we actually want, oxygen, which means we can turn all those wonky gases that are mucking up our storage into freeze-on too. So watch the other video for that. Have fun. Make some money.